there are infinitely many primes of the form n factorial plus or minus 1. Also, there are infinitely many primes of the form a prime factorial plus or minus 1. Prime factorials are basically product of all the primes less than or equal to a particular prime. Interestingly, these questions are still an open problem. And today we are going to discuss about a few instances where factorials and primes share some really beautiful relations. Mathematician Reo F had conjectured that if we consider Q as the least prime, which is greater than the prime factorial of another prime P, then the difference is a prime. Now, in case there exists a prime dividing this expression, we can clearly say that it's greater than P. This is actually pretty obvious, as we know that Q is a prime and the prime factorial consists of all the primes less than or equal to P. Hence, for sure we can't take any prime as a common factor from here. Mathematician Selfridge had observed that the truth of this conjecture actually follows from Schinzel's formulation of Cramer's conjecture, which says that for every x greater than this particular number, there exists a prime between x and natural log of x squared. But there's a problem. Schinzel's conjecture is attributed to Cramer, but Cramer had conjectured the following. Unfortunately, this doesn't imply the existence of a prime between x and natural log of x squared even for sufficiently large values of x. A more hopeful yet a difficult one is the conjecture by Erdos and Stewart, which says that the following are the only instances where this condition holds. So, on the number line, if we take any three consecutive primes named as the following, and then take a natural number between the first two closed at the first prime, we get the following. Erdos had also asked if there are infinitely many primes such that p minus k factorial is a composite number. And yes, of course, p is greater than k factorial. Now, this is indeed a difficult question. A slight easier version says that there are infinitely many natural numbers n lying between two consecutive factorials such that all of its prime factors are greater than L, and for which all the numbers n minus k factorial are composite. Next we have one of the most famous theorems, Wilson's theorem, which says that for every prime p, it divides p minus 1 factorial plus 1. But we are curious if its square also divide the following. We have instances where it's true, like for 5, 13, 563. But are there infinitely many? Well, at least not more than 3 below the number 5 times 10 to the power of 8.